Video is on conditional probability. This is when the probability of one event depends or is conditional on another event. There's a formula for conditional probability, and it is that the probability of A given B is equal to the probability of A intersection B. And don't forget, in the context of probability, intersection means and, over the probability of B. In this context, I'm making the assumption that B has happened, so it is the given event, and A is going to be affected possibly by B, so it is called the dependent event. Another way of phrasing this is to say, if B has happened, what is the chances of A happening? One really useful way of dealing with conditional probability questions is to use tree diagrams. And I'll talk you through an example now to show you how to do these. So here's my example. Here I have some magnetic letters. I'm going to select a letter at random, and given that it is blue, I want to find the probability that it is an A. In this case, the letter being blue is the given event, and it being an A is the dependent event. So I could write this question using notation as find the probability of A given blue. So here I have my page laid out for a tree diagram, and I can see my different possible options up the top, and the question that is find the probability of A given blue. So when I'm setting up my tree diagram, it's a good idea to put my given event in my first column, and the given event, of course, in this case is the letter being blue, and my dependent event in the second column, and that's the letter being A. So when I'm focusing on the given event in the first column, and I'm thinking about blue, my two options are that the letter might be blue or not blue. And I'm going to use B and NB to represent these. Just with reference to my letters here, I'm not sure how good the light is, so just to point out they're green, purple, orange, blue, blue, blue. So the probability of selecting a blue letter is going to be 3 out of 6. And the probability of selecting a letter that is not blue is also 3 out of 6. If I selected a blue letter, the chances that I selected an A are 1 in 3. And I'm going to say not choosing A, I'm going to call it NA, is 2 in 3. I'll have the same outcomes for the situation in which I didn't pick blue, but the probabilities here will be different. So if I picked a letter to start off with that wasn't blue, well then it was definitely going to be an A. So there was a 3 out of 3 chance that it would be A in that case, and there is a 0 in 3 chance that it would not be A. Fill in yourself now the outcomes and the probabilities, and just do your double check to see that your probabilities add up to 1. And here are my outcomes, and here are my probabilities. And now I want to use this information to work out the chances of selecting an A given that I selected blue. But first I'm going to think back to my formula. And my formula in this case is the probability of A given blue equals to the probability of A intersection blue, or A and blue, over the probability of blue. So I need to go to my outcomes and identify the ones that suit my criteria. So the probability of A and B, well, I look for an outcome that has A and B. And I can see it quite clearly here. It's this first outcome, BA. And so that is 3 over 18. And I also need to identify the probability of B. Well, the probability of B is going to be all of the outcomes that have B listed in it. So this outcome has a B listed, and this outcome has B listed. So the probability of B is those two probabilities together. And in this case, that makes 9 over 18. And when you calculate your solution for this then, 3 over 18 over 9 over 18 works out as 1 over 3. So if you've selected a blue letter, then the chances that it was an A was 1 in 3. Now, I must admit, this method is slightly overkill for this particular example, because if you look back to my original letters, obviously, if I was selecting a blue letter, there's 1 out of 3 in that group. that is an A. However, the method works in the simple case, and sometimes you can be dealing with much more complicated questions, but the same concepts